some of the reactive web features in the Spring Framework 5 and Spring Boot 2 generation in a Spring Boot context. So an essential question is why would you even care, right? Why do we care? Why reactive? Spring is traditionally, for 15 years and counting, already established in the Java space. And in terms of web architectures, primarily for servlet-based web applications. In modern-day web architectures, we are starting to hit the limits of, well, servlet container thread pools, of the servlet container invocation model. So from our perspective, it is a very interesting challenge for the framework to allow you to choose a different kind of web architecture. And a web architecture with different trade-offs. No servlet containers, no thread per request processing, no blocking I/O operations. Totally different setup, an event loop with just a minimal number of threads. The number of threads matches the number of CPU cores. A reactive kernel set up above it, and a programming model that allows you to tap into the power of this reactive processing model very easily. The decision that we made is to turn this into a dedicated, separate module, a separate web stack. So in Spring Framework 5, there's actually Spring Servlet MVC as one option, as a direct migration option, and as an option for new applications. And in parallel to that, there's Spring WebFlux. So this WebFlux term is basically our kind of brand name for the reactive web stack. And in Spring Boot 2, you get to choose between the classic, the traditional web starter, and the web reactive starter, which will bring you a WebFlux setup on Netty. So for the purposes of this session, we're basically going to start at the very beginning, right? How do you even express yourself in a reactive processing architecture? And an essential piece of the puzzle is Project Reactor. This is essentially a kind of tightened up version of RxJava. It's a reactive composition library, a library for conveniently and expressively building a reactive processing pipeline. So that's what we're going to start with, and then we're going to go from right there into its use in a Spring WebFlux architecture. And where do we start?
We're going to start today at my second favorite place on the internet, start.spring.io. How many of you know start.spring.io? I'm just curious. This is my second favorite place on the internet. My first favorite place on the internet, of course, is production. We love production. You should love production. You should go as early and often as possible. You should bring the family, bring the kids. The weather is amazing. It's the happiest place on earth. But if you haven't begun your journey to production, if you're not already in production, then you can begin your journey here at start.spring.io. If you need inspiration in the early morning before a cup of tea or coffee, start.spring.io. If your children are restless and can't sleep, start.spring.io. And if you suffer from indigestion after a long night of alcohol abuse and PHP, start.spring.io. So we're going to build a new application today. We're going to build a new application here to demonstrate some of these concepts. And the goal, as Juergen just alluded, is to build an application that takes advantage of these reactive primitives with the idea that we want to build something that will better withstand more requests for responses that are long-lived. We want to be able to withstand more demand for long-lived requests. Oh, yeah. All right. Good stuff. We want to be able to withstand longer requests. And to do so in a scalable way. So we're going to build a new application today using the start.spring.io initializer. We're going to call this a reservation service. We'll have an application entity called a reservation. I don't really all that much care about the domain of the entity itself. I just want to have something with which to work. We're going to use Kotlin here. How many of you are using the JVM? I'm just curious. Any language will do just fine. Obviously, they're all great choices. We have here support for Java, for Groovy, for Kotlin, all good choices. I'm going to use Kotlin because it's a nice language. All of them are fine choices, but there are some nice DSLs that express themselves more readily using Kotlin. It's also the language that Google just endorsed for Android, for example, so it's got a large burgeoning community. And we're going to build an application today using Spring Spring's reactive web support. This is the WebFlux module that we just talked about here a minute ago. We're going to use the actuator for operational concerns. We're going to need what else are we going to need? We're going to need maybe gateway if we have time for that. We'll come back to that later. Maybe security, yeah, Reactive Redis. So we're going to need a few bits here, Reactive Redis as well. So a lot of different things here, but we also need some sort of persistence store, a lot of different persistence options here. And again, to see the full list, I could switch to the full version, whereupon I'll be given a veritable ocean of different checkboxes that I could elect to include in my application. But you'll notice that for all these different SQL options, none of them say reactive, and that's because, well, they're not reactive. Fundamentally, JDBC in the Java platform is a blocking thing. It's not particularly useful in a reactive context because ultimately there's going to be a socket that's going to block waiting for I/O, and during that time, that thread that's being used to process that I/O is unavailable. It's being monopolized by that thread, so by that I/O rather. So rather, we're going to instead prefer some of these options that support natively reactive processing. And here you can see a number of different options that are seemingly twins. We have Redis and Reactive Redis, but we don't have options for everything. There's just a small subset of options that support reactive programming. So we have a couple of options here, 4 different options in fact. Reactive Cassandra, that's a fine choice. If I had that in my machine, we could very well use that for the domain that we're going to try and express today, but I don't have it for now. Reactive Couchbase, another fine choice as well. We could certainly use that if we wanted to. Redis, we might come to later if we decide to do rate limiter and gateway, but we're not sure about that. And so we're left now for our main data type, we're left for our main data store, MongoDB. In particular, reactive MongoDB. Because when you want to lose your data, and you want to lose it reactively, there is nothing better than reactive MongoDB. So we're going to go ahead and add that to the application. And then we're going to go ahead and generate. So we now have a new application. We're going to generate a new application here. We have a number of different drop-down menus here, and these drop-down menus imply choice, where I'm afraid there really is no real choice. The first drop-down here is the version of the JVM that you'd like to use in 2018, early 2018. You see, Spring Framework 5 and Spring Boot 2.0 and all the other bits that build upon that, including Spring Security and Spring Data, all expect a Java 8 or better baseline. So really, we're at the lower bound, we require Java 8. Going to the upper bound, these other versions are short-term, right? So they only have 6 months life cycle. So
and we're waiting for 11 to appear, but of course that's only happening in September, right? So for the time being, we take the most sensible option, and that is Java 8.
Java 8. So really, there's no choice. Just choose. Just let the tool do the selection there for you. And then here we have the choice of packaging. Now you may know in the Java world we have 2 different types of packaging: .jar and .war. Right? .war are applications that are deployed in traditional servlet containers, and .jar are, well, it's the default what we have here. So people get confused about this. They don't know when and where to choose which. So let me do my level-headed best here and now to explain when and where to choose which. If by some fluke of physics, some terrible tragedy of time-space, you should find yourself somehow transported to the distant past, far, far, far beyond modern help, then choose .war. But if you're here with us in 2018, then choose .jar. This is a big part of our overarching and guiding personal philosophy of make jar, not war. Again, lots of choices, lots of options. But we're going to leave these selections as they are. We've now generated a new project. We're going to go ahead and open this up. I'm going to go to my downloads directory here, CD downloads. And there it is. Open that up. And I'm going to open up in my IDE. I'm going to use IntelliJ. Just curious, how many of you use IntelliJ? It's a fine choice. What about Eclipse? Also a great choice. Anybody using Eclipse? Rock on. Good stuff. What about NetBeans? Anybody here using NetBeans? Also good choice. Right on. Rock on. Okay, well.
There's always a person, right?
Right. What about Emacs? Emacs, are you here, sir? Where's the Emacs guy? Yeah. It doesn't seem to. Oh, there he is. It doesn't seem to matter.
The Emacs guy.
It doesn't seem to matter which city, country, or continent we visit. It's always the same human being, the same one, every time. Who uses Emacs? I do, and then he leaves, presumably to go to the next conference to troll again. It's bizarre. Anyway, we have now this application. We're going to go ahead and comment out some of the bits that we don't need just yet. We're going to go ahead and comment out Spring Boot Starter Security to get rid of the security support for now. We're going to get rid of the gateway bits because, again, we may not have time to get to this. It's only 45 minutes, and we could talk for 4.5 hours. So let's leave these choices as they are. We're going to go ahead and comment out the Redis support here, right, as well, for now. And we're left now with WebFlux, with the actuator support, the Kotlin support, and so on.
And with Reactive Mongo, right?
And Reactive Mongo, I should see that in there somewhere. Did I not? Yeah, there it is.
Yeah,
MongoDB.
there it is. Yeah, there it is.
Very cool. So now we have a new application, reservation service application.kt. This is a Kotlin application. This is the entry point function into the application. And here's the top level class. And what we're going to do is we're going to build an application that persists data into MongoDB, right? So, and I use that term persists charitably. We're going to create a type to map our data. So we're going to say data class, and we're going to call an entity called reservation. And it's going to have an immutable read-only field called ID. That is a string that is also nullable, so that's why the question mark is there. And it's going to have another field called reservation name. And it is going to be a string, and it's going to be nullable, that's the question mark, and the default value will be null. So this actually creates a document that has a primary key, or a document ID, or document key, and ID, there we are. And that's it. That's the entire thing. That'll create getters, setters, toString, equals, all that kind of stuff for the entity. And now what we want to do is we want to be able to persist instances of this data into the database to be able to read, write, manipulate, et cetera, to query, the basic CRUD style life cycle. So we're going to create a repository. We're going to use Spring Data Repository to do that. And we're going to extend the reactive Mongo repository. So this is going to manage entities of type reservation whose primary key is of type string. And there, we have actually, we could just leave it like that. This repository, very similar to all other Spring Data repositories, implies certain behavior, right? Certain behavior out of the box. Spring will turn this interface definition into a concrete class. And this concrete class will support reading and writing and working with data in terms of these types. Well, in this case, it's going to support inserting records of a given type, and it'll accept a publisher. A publisher comes from the... Hi, buddy.
Just to make sure it doesn't run out.
It's okay. It's
Perfect.
not weird. Thank you. So a publisher is a type that comes from the Reactive Stream specification. This is the underpinning specification that allows Project Reactor from the Pivotal team, from RxJava, from Netflix, from Vertex, from Red Hat, from Akka, from Lightbend, all these different projects support the Reactive Stream specification. And this is the computational metaphor by which we say, I have a thing that will produce a potentially unbounded amount of data eventually, asynchronously. Not now, but maybe later, maybe 1 nanosecond from now, maybe 1 year from now, right? So I have a publisher. It emits items of type T. A subscriber consumes those items of type T. When the subscriber subscribes to the publisher, it is given a connection to that publisher called a subscription. That subscription is a session. It's a link between the producer and the consumer. It is through this subscription that the subscriber gates the production of data from the publisher. It signals to the publisher that it wants to throttle the number of records that are being produced so that it can accommodate as much as it can handle and no more.
Yep. It actually is a very simple mechanism for collaboration at the lower level infrastructure level. So this kind of mechanism called backpressure, a kind of subscriber-driven stream interaction, only really happens between the pieces of your infrastructure, between the HTTP engine, between your data store driver, anything that is involved in the pipeline. And it actually the effect goes both ways. It is a totally non-blocking interaction model. So we can both control that the publisher doesn't just pump data to the subscriber would be unable to pass it on. That's kind of one effect of controlling the flow. The other effect is, of course, if the publisher is not ready quite yet, the subscriber is not actually waiting for the data to arrive. There's a notification model. Whenever the publisher actually has the next element of data ready, it will perform a callback to the subscriber and kind of let the subscriber pass it on. In a web architecture, the publisher might be the result of a query against the data store. And the subscriber might be the HTTP response that you're sending back to the client. So there's kind of networking involved on both ends. And this is exactly what Reactive Streams is about. It's about I/O streams, potentially, bounded by factors that you don't control. And the interaction model only uses a thread, only actively uses a thread when there's actually work to do. So a very minimal number of threads can handle a very large number of requests, a very high load. And in particular, it is even under very intense, very extreme conditions, still able to accept further requests coming in. Imagine just a server that is really busy with all sorts of work with all sorts of waiting on an external data store, and then an innocent little index HTML request comes in. Are you able to serve it, right? That is the kind of question such an architecture has a very immediate and very comprehensive answer for, whereas in a server container model, you might be out of luck under certain conditions. So we've already mentioned publisher as a central element type. Can we quickly open Reactive Mongo repository once more?
Yes.
We're going to see it right next anyway, but there's already the return types showing up here. So mono and flux are higher level composition types coming out of Project Reactor. Both of them implement publisher. So they are reactive streams publishers, but they are quite rich handles. You can programmatically transform the data that comes out of them. You can pass them on. You can connect them into a pipeline. So there's a pretty rich composition API. If you have any experience with RxJava, this is basically the equivalent. A mono is a single element or none to be produced, and the flux is a sequence, potentially even unbounded sequence of elements that corresponds to an RxJava single or an RxJava flowable, or in RxJava one terms and observable. So they serve the same purpose. And in terms of our signatures, we chose to use flux and mono very explicitly on the return level because they indicate certain semantics, this one element or none or the stream. And they just allow you to just take what you get from like a repository and build against them, compose from right there. All right, and that's exactly what we're going to do now, right?
Right on. So with that background in mind, let's go ahead and write some data to the database. So what I'm going to do is I'm going to register an object of a certain interface that Spring will then pick up and invoke when the application starts up. And so normally in Spring, you might, for example, be accustomed to saying that you're going to contribute a bean, which is a method. You have a bean provider method that's going to produce a bean, and you're going to then process that. We're going to expect Spring to process the result value, the return value from that. And this is going to be a bean of type application runner. So here it's a lambda. It's an interface that can be written as a lambda. It has one abstract method here, void run. And here I can express the arguments like that if I want to. But since it's only got one argument, it's implicit in Kotlin. It can just be called it if I really wanted to get access to that variable there. Now I could certainly do this, but in Kotlin, since we're doing this nice sort of functional and reactive world, we also have this ability to take advantage of this extra API here where we can actually add initializers, and we can use a nice DSL here in Spring Framework 5 for functional bean definitions. So I'm going to create a bean, like so, of type application runner, and the application runner is going to look up a reference to the repository there, repository equals ref, and I'm going to use the reservation repository. So there we are. There's my reference to that. I'm going to contribute the bean. And in this bean, we're going to go ahead and write some data to the database. So I'm going to start off with some names. So names, we're going to say val flux.just, and we're going to go ahead and use some names. So Juergen, how are you doing, my friend? I'll add you. I don't have the, is it umlaut?
Yeah.
So I'll just do the, there you go.
Yeah,
sorry.
please, thanks.
All right, and Josh, and I need some other volunteers. Who wants to be, what's your name? Robert. Very cool. That's 3. Sorry? Emacs guy. Nah, I need a real name. Come on. What about you, buddy? What's your name? How do you spell that, my friend? Like so? Very cool. Nice to meet you.
Any further volunteers?
Miss, what's your name? How do you spell that? Like that? Sorry. Like that? Very cool. Nice to meet you as well. What about you, buddy? What's your name? How do you spell that? Oh, seems like a very common name. Good stuff. Nice name. Miss, what's your name? Yeah. IRIS? Like that? Okay. And nice to meet you as well. And one more. It's so hard. There's a giant spotlight on me. So
he won't stop. You need to give him a
Miss,
name.
what's your name? Yeah, you. With the, yes. No, Miss. How do you spell that? Lamea? A. Like that? Okay, very cool. I can barely hear you. I'm so sorry. All right, very good.
All right, I think it's...
So that's 8 names. It's a nice round number. What we have here is a publisher, right? This is actually a publisher of type string. So publisher of string, 8 names. And I'm going to manipulate those names. Actually, it's a flux, but I wanted to show you it's a publisher. So we're going to now manipulate those names. We're going to take each name and turn it into a new reservation. So I'm going to create a new reservation object like so, setting the reservation name attribute there. I'm going to pass in it. It is the name, the string there. And that'll give me a publisher of reservations. So reservations. And from there, I want to actually take the reservations and I want to write them to the database. So I'm going to say val saved equals reservations dot map. And I could do this. I could say, repository dot save and save it. And it, in this case, is the reservation that we created. So the result of this, it looks compelling, but actually it's a little bit, it's not quite what we want. You see, if I were to type this out, the long form, what I would actually have is a publisher of publishers of reservations. The map operator accumulates whatever comes back from the map invocation and accumulates it in another publisher. Well, I don't want a publisher of publishers. I want to unpack the intermediate type there. So I'm going to say publisher of reservations using flat map. Okay? There we are. Now, I can unpack that now that we know that that's going to work. Now, this looks promising, doesn't it? I mean,
yeah. It knows how to produce reservation objects and save them, right?
Right.
Now.
Saved, we're all good. What do you think is going to happen if I run this code? Exactly. Nothing, right? Nothing is going to happen. This code, as written, is useless, like myself. This code you need to coerce this code to do anything. There's a pipeline that we've just defined, but it's not going to do anything until we've actually subscribed to the results. So we could say subscribe, right? And there we are compelling all 3 lines before it to activate, to trigger, to execute. So subscription is, this is the part of the reactive stream specification. We could use the overload that takes a subscriber, but there are many other overloads from the Reactor project that take just, for example, a consumer, and that's what I'm using here, is this here. Now, this is fine, but how many of you know the expression, a broken clock strikes true twice a day? It means that if you have a broken clock, and the hands are frozen on the clock, it doesn't matter, it's broken for most of the day, but there are 2 instances in the day, in the morning and in the evening, where the clock is correct, right? A broken clock strikes true twice a day. And the same is true for MongoDB. Sometimes, not always, sometimes it will write data to the database. Most of the time it loses it. And I know they work hard to lose it all the time. But sometimes it gets through. So what I want to do is I'm going to delete some data. I want to delete the database, so that way we don't have extra redundant duplicate data, okay? So I'm going to delete everything first. So I'm going to say repository.delete all, and then you can see that delete all returns a mono. So I'm going to say delete all, and then I want to force this to happen before everything else. Oh, yeah. Oh, wait. Come on.
Okay.
Get up. People are waiting.
We're only going to continue if you stop.
Now, so delete all. I could say subscribe. That's certainly one option. I could subscribe here. But that code, therein lies another subtle bug. If I subscribe, this is asynchronous, right? This is going to happen asynchronously. There's no guarantee that this line will finish before these lines. So we want to force this to execute before. And I could say .block, but this is a terrible way to do this. I showed this code to my partner, Tammy. I said, Tammy, darling, love of my life, what do you think of this code? And she looked at me as though she had made the worst and most terrible of mistakes in choosing me. She knew that this code is not the right way to write this, to solve this problem. We need to use the operators in Reactor to be able to compose so that it's deterministically going to execute one before the other. So the way to do that is to then say then many, and to take the publisher that we've just spent all this time creating here, and then pass that in, okay? So I'm going to say val saved, that's the whole thing, right? I'm just chaining them all together. I can take that whole thing, like so, and pass that into this. And then I can say repository.find all, and then I can say I want to subscribe and print out the results. So I'm going to get rid of that. And you can see the code, if you look at the code, it's one line that's executing, then this line, then this, and then finally this. There's a lot of asynchronous things that are happening here in different threads. And yet, because we're using these operators, things are happening in the way that they should. And we can even control, for example, on which threads things happen by providing a scheduler, right? So this is very complicated asynchronous code, and yet there are no countdown barriers, cyclic countdown barriers, cyclic latches, or phasers involved here, right? We didn't have to do any complex multi-threaded code with semaphores and all that stuff.
Yeah, it's a fine recipe for how to arrive at the sequence of operations, right? Triggered at the very end through the subscriber. So it's this is essentially the reactive streams model at work for a relatively simple and straightforward purpose. So let's run it, right?
Let's run it. Should be fine. Let's see what we get. Oh, yes. Compiling. First time's always the worst. Seriously, why? All right.
There we go.
Look at that. It worked. Of course it worked. It was a demo. What were you expecting? It was always going to work. That's not why we're here, friends. What I wanted to talk to you about was this. This is the Ascii Art in Spring Boot. This Ascii Art took a long time to get right, but you see, we on the Spring team have many people who are doctors, PhDs, people in their previous lives worked in nuclear physics. Very, very intelligent people. So it makes me very happy to imagine that someday, somewhere, somehow, there was a GitHub issue that says, darn it, we need good Ascii artwork. And I think you'll agree they did a great job. So it's for this moment, it's for this reason that I want to take just a brief digression to talk about what I consider to be a very serious and glaring deficiency in the IntelliJ JetBrains product. For while I'm a fan, I consider this to be particularly short-sighted. Do you see that checkbox? It says hide banner. What the hell? Why is that even there? That's a dumb feature. So I did what all people would have done in that same situation. We're not heroes, none of us. I did what all people would have done in that same situation. I went on the internet and I cried. And I sent a message of hope from my friend Jan Sebron. Jan Sebron is a Twitter page away that's not loading because Wi-Fi. Get off of him. Let's see. Tethering. Oh, this is the second time. Mm-hmm. Is Twitter down or is the Wi-Fi not great right now? Let's go ahead and
make your bets.
There we are. Oh, I just had to move it. Okay, so there we go. So Jan, he's a software developer by passion at IntelliJ IDEA JetBrains, and he responded with this message of hope, which I share with you here today now. Don't worry, my friends. Hope springs eternal. Good old Jan. Now, anyway, that patch is still pending. I mean, that was 2016, so I assume it's in the next release, surely. So anyway, one thing, we have this great Ascii artwork. One thing that people often ask me is, can I change the Ascii artwork? And of course, that's a ridiculous question. Even now, as we talk about it, I resist the urge to flip the table and leave. It's insulting. But that said, if you feel like you can do a better job, if you feel like you're that good, I'll show you how. And there's a couple ways to do this. One is to copy your own banner.txt file, right? So banner.txt. Two are the downloads, reservation, service, source, main, resources, banner.txt, right? And now, having done that, cd downloads, reservation service, maven, clean, spring -boot : run, and got that, okay. Pretty good, pretty good. But one of the biggest features in Spring Boot 2.0, which we just released just a month ago, 2 months ago, very recently, one of the biggest features is this. We've taken Ascii artwork to a level beyond. Yeah, sure. I don't even care if it adds like 30 seconds to the startup time. Don't even care. Totally worth it. Amazing. Awesome. So anyway, I will actually have to remove that for now because it will take an extra 30 seconds that we don't have.
Yeah.
RMRF target. All right, so what do we do now, buddy? We've got this.
Yeah, we saved some data, and hopefully it's actually there.
Got
now
great
we'd
Ascii
like
Art.
now we'd like to expose it, right?
Yeah.
On a nice little HTTP endpoint.
Okay.
So how do we go about that?
Well,
This time, do we stick with Kotlin?
yep, Kotlin.
Yeah, okay.
Go ahead and explain. I'll go ahead and write the
Right.
code.
The web endpoint model in Spring WebFlux comes in several flavors. There is actually a Spring MVC style model with add controller, add request mapping, add get mapping, and so forth, being very similar to the model as introduced back then in Spring MVC and as popularized for other kinds of endpoints across the Spring portfolio. We have that for WebFlux. Slightly differently purposed because each of those methods needs to build a Reactive Streams publisher. So simply speaking, for an incoming request, the Spring WebFlux server stack wants your code to build a pipeline for this request for how to arrive at a response. Doing this within the annotation-based model is one way, but the kind of new flavor in Spring Framework 5 is functional endpoint registration. So both with Java and with Kotlin, we have ways of composing what we call router functions and handler functions. A router function is essentially just saying, for this kind of incoming request, let's match against the predicates and kind of forward it to a particular handler function. The handler function knows how to take the incoming server request and arrive at the server response. It doesn't actually process the request, it just builds a pipeline for how to process the request and leaves it up to the runtime system to trigger that pipeline. So the runtime system is in charge of waiting until the request is fully parsed and then registering a subscriber for the response and actually triggering the next elements from this publisher as the HTTP response is ready to be written out. And syntactically, this can be super sweet and concise, right?
Absolutely. Look, so there's our HTTP GET endpoint. I created a bean of using the router DSL here, and then I created an endpoint called GET. I request predicate called GET that says I'm going to match any HTTP GET requests, and of course I can compose. I can say and, content type, whatever. I can do all sorts of other things. I can also provide my own custom request predicate. So, it dot whatever. I can work with that, and if I want to return true or something like that, if I want to do some sort of dynamic test to look at the whether Mercury is in retrograde or whatever I want, I can do all sorts of custom predicates there. And then I provide the response. And the response, of course, in this case is just the payload coming from the repository find all method, right? The publisher of T.
The repository is basically our publisher for the body of the response, right? So we'll take that body, that's why we pass it into a body method, right? But we also need to provide kind of the status of the overall response, and that's what we're saying with OK here. It's basically the HTTP status, potentially headers to be added and so forth, right? Then the body coming from this publisher, and that's what we return. That's what is being triggered by the runtime system.
Now, worth noting that you just mentioned a minute ago, succinct. Worth noting that we can actually cut this out. This is, this is sample data that we're using for our demo here. But this is the whole production application, right? This is the REST endpoint and the reactive data access is all but 34 lines in Kotlin. It would be maybe 36 lines in Java. It really isn't that much of a difference between the two different languages. I only have this there because we wanted to have some sample data there. So now we have a REST endpoint, right?
Yeah.
And that's actually taking the payload of type T back and we're turning it into JSON. Well,
there's a codec model underneath, which is kind of cleverly defaulting for us, for our purposes here, but it's actually a configurable codec model. So based on the desired content types, an underlying codec is in charge of taking those elements as they arrive from the body publisher and kind of transforming each of those elements through the codec into an element, in this case a JSON element, in the response stream. So this happens underneath the covers. Similar to Spring MVC's HTTP message converters, there's a reactive codec model underneath the covers here. Just like for the data stores, a codec really should be ready for reactive processing. Just like we select a data store with a reactive data store driver, we only have a few codecs that are properly reactive. We have a Jackson-based codec. We have an XML-based codec
We had to
against
submit
Alto.
pull requests to Jackson to make
Yeah,
that
yeah.
work too.
Actually, that was kind of a collaboration almost in Jackson 2.9. So, because what good is a rendering library that has a blocking render operation for the entire response, right? We really need a fine-grained interaction with the rendering library to trigger the rendering of individual elements that fit into the buffer. So that's why. And to some degree, this is what it's all about, right? Taking the reactive power of those pieces of infrastructure that you already have around. Like, say you've already chosen Mongo, Redis, Cassandra, and you have a reactive driver for it. Exposing the power of this interaction power, this reactive interaction power that the data store driver provides, exposing it throughout your web application to the HTTP endpoints and back down, like the entire system, exposing that reactive power and making the best possible use of this interaction model. This is what Spring Web Flux is all about. It goes in both ways, of course. If you have blocking data store APIs, or if you're using codecs that are totally blocking, if you're using rendering, template rendering with a blocking render operation, you're probably better off in the servlet-based model that Spring MVC provides, where blocking operations are kind of part of the model, where there's a large enough thread pool to accommodate for that. You're going to have the best possible experience with the reactive model if all the infrastructural pieces are actually reactive.
Well, absolutely. Now, we have this reactive data access layer. We've got this reactive REST endpoint, and it didn't take all that much code to get it done. Now, are we ready for production?
Yeah, I think we are.
Close.
Or is there something missing?
We're missing a few things. Missing a few things, right? We care
That's
about
a shame,
production,
though.
right? This is Spring Boot, and Spring Boot cares about production-centric sort of applications. And so thus far, we've built an application that has all this stuff, but we've failed to care for day 2, right? What happens when this thing gets deployed into production? And I was just looking right now, just a minute, as he was talking, I was looking for a ticket where work is being done to support Dynatrace integration with Micrometer. You see, Micrometer is an API that we're going to talk about here now when we talk about the actuator. The actuator is a set of endpoints that you can surface to, that you can add to your application to surface information about the application at runtime. And these endpoints support observability. The observability, of course, is this idea that when something goes wrong at 3 in the morning, and it will always happen at 3 in the morning. You should know that by now. It's never like 2 in the afternoon when people are back from lunch and they're happy and they're excited to go back to work. It's always going to be 3 in the morning. So when something goes wrong, everything you can do to support remediation of that application is valuable. This is why we have Spring Boot Starter Actuator in the class path. But in order for us to use Actuator, we have to configure a few things. We need to, first of all, say that we want to expose all the different endpoints. So expose everything by the web, that's the first thing. And then for the health endpoint, we're going to show always the details. Okay, so I'm going to add those changes to my application, and I'll restart the endpoint, restart the application, having made those changes. Whoops. I've got 2 things running at the same time. Let's just go ahead and restart that one. And with that in place, I can now go to reservations. That's fine. That's the data. And we go here now to Actuator. I can see a set of endpoints here, including the audit events, the beans. The audit events are things that are related to, for example, if somebody uses Spring Security and then they authenticate, there's going to be an audit event that you can see there. The beans endpoint shows you all the different objects that the Spring Boot application has configured, all the different objects and how they're related to each other, their scopes, their dependencies, etc. You can throw that into a graph database. You've got the health endpoint. The health endpoint shows you all the subsystems in your Spring Boot application that might fail, including, for example, MongoDB and your file system. And of course, if you have custom things of which we're not aware, you can contribute your own health endpoint status there. We have the conditions endpoint, which shows you all the Spring conditions that were evaluated when the boot application was initialized, and whether they were evaluated to true, false, or whether they were just sort of run unconditionally. We have all the different properties that are that are supported for different customizations. For example, managing the trace HTTP endpoint and the properties, for example, that are required to configure that. We have the environment endpoint, which shows you the different system properties and environment variables and things like this, things that you can use to, at a glance, debug the deltas from one environment to another. We have the loggers endpoint, which actually supports more than just Git. You can actually post to this endpoint to dynamically toggle logging thresholds, logging levels for different loggers while the application is running. So suppose something is going wrong, it's in production, you want to debug a certain span of code, you can tell that application to turn on that logging level dynamically here. We have the heap dump and thread dump. Heap dump and stack trace are endpoints, and they both heap dump and thread dump. Yeah, they both provide a heap dump and a thread dump, right? So you can understand what the application is doing and throw that into a profiler. We have the metrics endpoint. The metrics endpoint shows you all the different keys and values about your application that you may want to understand what's happening. These are things that your application can emit for you, things like your system CPU count, the JVM memory, the max, the allocated memory, etc. But you can also inject an instance of type meter registry, which is provided by this library called Micrometer. Micrometer is a library that we at Pivotal built to support usefully collecting dimensional metric data. Right? So when I say dimensional metric data, I mean data that has keys and values associated with each metric. So think about if you wanted to collect information about metrics about HTTP requests that were made into the application. You'd have a metric called http.requests. Well, what if you want to also now have a metric that supports how many HTTP requests you have that are of type GET? You'd have http.request.get. Well, what if you also wanted to have another metric that supported all those that returned HTTP status code 200, http.request.get.200? And so this becomes a sort of a Cambrian explosion of labels for your metrics. It gets very confusing. With a dimensional metric store, something like Prometheus or Netflix's Atlas or any of these other different supported metric systems, including Datadog and Graphite and Dynatrace and New Relic and StatsD and SignalFX and Wavefront and all these other sort of options, you can say, I want to collect just the metrics for HTTP.requests and then attach metadata to that. You can say, it was an HTTP GET, yes. It was this status code, okay, and so on. So you can then query that later on. This is a abstraction that lets you talk to these different metrics facades or metrics stores or time series databases or monitoring systems. Obviously, the only real choice, is Dynatrace. Obviously, we wouldn't recommend anything else. But the point is, you can use this tool to very cleanly and concisely talk to those different stores, and you can capture custom metrics. Things like, the KPIs, how many requests, how many orders were processed, how many people signed up, how many products were shipped, etc. These are things that you can capture in your Spring Boot application and have it transparently, thanks to Micrometer, talk to the back end. So all these different endpoints are provided for you out of the box. And of course, if you're using a platform like Cloud Foundry will surface all of this in the Apps Manager dashboard. You'll get a single pane of glass that shows you all of this kind of information for all of your applications, for all your application instances in a single place, right? And then that, of course, integrates nicely with things like Dynatrace. Now,
in particular, if you've already or maybe seen some of this in Spring Boot 2.1, give it a fresh look in Spring Boot 2. Yeah. The Micrometer support is brand new there. There's a couple of new things. So there has been a serious overhaul, a very comprehensive revision of the actuator model and the default endpoints in Spring Boot 2. And so most of this is kind of brand new, or at least brand new revised, right?
Right. So last year, Juergen and I spoke at the CERN, the Voxed CERN conference, which is it was in CERN, and you may recall in CERN a few years ago they announced the discovery of the Higgs boson particle, right, which is the sort of this particle that they had hypothesized was possible, but they didn't have proof. The scientists were out; they couldn't conclusively prove that this thing was out there, and they finally found it a few years ago. And with that same sort of hushed caution and hesitance, I do want to bring up the possibility. Again, this is just a hypothetical. I don't know if it's possible. The science is not there yet, but it is possible. And again, hypothetically, really important to stress hypothetically. It is possible that there are people building applications without Spring and Java. And again, I haven't met these people, but if those people are out there, then Micrometer also works outside of Spring, right? It works best with Spring, of course, but it works without if you need it. And this is also working in a reactive world. It also works in Spring MVC, and it also works with just JAX-RS and Spring, right? So the Micrometer thing is a really convenient thing. Now, this is production-minded. I like this. I like what we just showed here. We are, I think, a little long on time, but I don't really care. So I'm going to show you one more thing.
We've got a bonus topic for you.
Yeah. I just want to show you one more thing. You see, now that we've kind of taken a look at all these reactive concepts and we understand this idea of a publisher, we can take that knowledge to a lot of different places. We looked at reactive web applications, reactive data access, but this is just the very beginning. We also support reactive security, as we talked about before, reactive messaging with Spring Cloud Stream and RabbitMQ or Apache Kafka. We also support a reactive gateway product called Spring Cloud Gateway, which is like Nginx or Mod Rewrite or Kong or Apogee or whatever. These are sort of, it's a gateway technology that works in Spring. And we have a number of different use cases that are well supported by reactive programming, including function as a services, right? Function as a service platforms. So we have a project called Spring Cloud Function, and Spring Cloud Function lets you do just that. It lets you describe functions that you can deploy to function as a service platforms. Like, for example, there's this company in Seattle that maybe one day will be big called Amazon. They have a platform called Lambda, and that is a destination you might want to deploy your function as a service applications onto. There's Google and also Microsoft. They all have function as a service platforms, and we have one as well called Project Riff, which is an open source Kubernetes-based function as a service platform. It's very easy to deploy onto any Kubernetes install, and I have it running on my local machine here. So you can deploy functions that run on this platform very easily, and so that's what we're going to do. We're going to build a simple function called uppercase. It's going to be using I'm just going to use Lombok, basically. That's the only thing I have time for, so we'll generate that. And I'm going to add the function as a service Spring Cloud Function library. So UAO, come on. Oh. See that unconfirmed? That's the Wi-Fi.
Where does that come from?
There it is.
Yeah.
It's downloading. So UAO, uppercase. And what I'm going to do is I'm going to add the Spring Cloud Function library. And again, you can write functions using Spring Cloud Function and do so in a way that's independent or agnostic to any particular function as a service platform. And you can take advantage, of course, of all the different services. Let's see, CD uppercase, open pom.xml. You can take advantage of all the different services provided by those different platforms, but do so in a way that it doesn't lock you in. So if you want to move from one vendor to another, you can absolutely do that. I'm going to go ahead and add a few bits that aren't yet on the Spring initializer there, not yet. So I'm going to add some dependencies here. So Spring Cloud Function dependencies, scope, import, type, POM, rolls right off the tongue, and Spring Cloud Function Webb. All right, and with that in the class path, I can go ahead and build this very simple function that we'll demonstrate here. So bean function, this is a Java util function that takes a publisher of string. It's going to return a publisher of string, and this function is going to be called uppercase. All right? So you can see the reactive streams types are there, and we're going to build a new function using Java 8's Lambda support here, and the function will take the input publisher, and we're going to map each item in the input to an uppercase, and we can rewrite this, of course, using Java 8 Lambdas. Cleans up nicely. So there's our single function definition, very, very simple. And in Project Riff, functions are separated by Kafka topics. So I'll do maven clean package. And then I need to deploy this function to Project Riff. Now I've got Project Riff on the background here. If I do riff list, you can see that there are no functions deployed just yet. So I'm going to now deploy this, and I can say, come on, Josh, bin, riff, Java, where's Java? Riff Java.sh, and cat this one, it's going to be the name, the artifact, and the handler. So the name is uppercase. The artifact is the target directory jar, and the handler will be main, and, it'll be uppercase, that's the name of the function, and main will be equal to com example, what did we say? It was com example uppercase dot uppercase application. Whoa. You have to invoke it, not cat it. All right. So what that did behind the scenes is it ran this function down here. That's the whole incantation. It's just a little long, so I always forget it. So it says riff create Java, passing in the artifact, forcing it. It says expect messages to come in on the Kafka topic called uppercase. Give the function a logical name called uppercase. The handler to invoke is called uppercase, and the main class is uppercase application. And use the Project Riff function invoker 006 snapshot. Okay, so there we go. Now riff list. All right, there it is. There's our function. Riff publish input uppercase minus D, and the payload will be hello, and the content type is application JSON. Okay. And we're going to say that we want to wait for the response to come back. So it's posting to the function as a service gateway. And if the Wi-Fi works, this should come back really quickly. Riff, publish.
The response would, of course, be totally surprising.
Publish.
The outcome. well, we might see it coming back still. The point here is that we're really taking the programming model, the underlying Project Reactor facilities and the Reactive Streams Foundation to quite some level. And even in this kind of functionally composed programmatic world, we're kind of taking a quite unique Spring style of expressing yourself to different domains, from web architectures, traditionally deployed web architectures, even to a function as a service model. And you've mentioned that Micrometer is an independent library, so is Project Reactor. So in case you really like what you've seen with Reactor, you can also play with it independently. It is an independent library just like RxJava, but Java 8 based, Java util function based, and quite oriented towards the server side, not making any compromises for user interface applications, which RxJava unfortunately still has to do, even in RxJava 2. Right,
well,
I guess that's all we had for today.